Hey everybody, here's another one. So this is number 2 for both the AB and the BC test for 2008. I think this one will be quicker than the first one, hopefully, for your sake and my sake. So part A, we've done this multiple times. You're approximating something. Rate means derivative. We're estimating, so we're not getting the exact value at 530, and we see that 530 is somewhere between those two times, 4 to 7. We can't get an actual value because we don't have an actual function. So how do you approximate? So real quickly, if I were to plot these points, 0, 1, 20, I'm just going to do a rough estimate. And then 1, it's a little bigger. At 3, we've got a point here. At 4, it's starting to decrease. 126 back down here. 5, 6, at 7, it's gone up a little bit. And then at 8, it's gone way down. And at 9, we're at 0. So roughly we have some kind of a curve. I don't know what it looks like, but I'm just going to roughly draw this. And so they want the derivative at 5.5, 5.5 hours, which we should know is the slope of the tangent line at 5.5. So it's kind of the slope of that tangent line right there. And if you have that mental picture, you should realize that if we find the slope between these 2 points, it'll approximate the slope of the tangent line. So what we could do here is we can say L prime at 5.5 is approximately equal to, and it's going to be the slope between those 2 purple points here and here, which will be L of 7 minus L of 4 over 7 minus 4, which is 150 minus 126 over 3, which is, what is that, 24 over 3, which is 8. So as I always tell you, you should read your question and make sure you've answered it. Use the data and data table to estimate the rate at which the number of people waiting in line was changing at 5:30. Show the computations that lead to your answer. We have done that. Indicate the units of measure. So this is where we have to be careful. L is people, and the bottom number is time, so it's hours. So our units should be people per hour. Whoopsie daisies. Oh no, what's going on? People per hour. 2 points. Woohoo! All right, we're going to crank along on this one because the last video was super uber long. And you guys are going to get tired of me. I'm going to get tired of me talking. So let's move on. So trapezoidal. So quickly, I'm going to remind you of the area of a trapezoid. So if we have a trapezoid like this, oh, that's ugly. We'll call this H1, call it H2, call that the width. The area, you have to know it's 1/2. It's kind of like a triangle, 1/2 base times height. The base will be H1, H2, but since there's 2 bases, the triangle only has 1, this has 2. We add up the bases and the width between it. So that's the area of a trapezoid. So again, H1 and H2 are kind of like the heights of the function, and the width is the change in time. So we're going to approximate. Oh no, we got to do more stuff. Estimate the average number of people in line. So to get the average of any function, we have to know that you integrate and divide by the width. So we're going to integrate the number of people for the first 4 hours. It's going to be 0 to 4 of the number of people divided by the width. I'll call 4 minus 0. Since we're doing a trapezoid approximation, I use a squiggly. And so I don't forget the 4. Ooh, that's a beautiful line, isn't it? So use the formula. 1/2 H1 and H2 are going to be L of 0 and L of 1. And the width between the first two is going to be 1. So I have that. And then I have to go from 1 to 3. So same thing, 1/2. And it's going to be the two H's, L at 1. Whoops, that's a 1. Whoa, back up. L at 1 plus L at 3. And the width between those two would be 2. Oh no, I'm running out of room. Plus. Okay, I'm going sideways. I'm turning this sideways. It's going to be 1/2. And it's going to be L3 and L4. L3 is the first height. L4 is the second height. And the width between those two is only 1. All right. This is going to work. So it's 1/2. It's going to be 120 plus 156. And then the next one will be 156 and 176. And the width of that was 2. And the last one is going to be 176, 126. It'll fit. Oh no. 126. It's going to fit times 1. And that's all over 4. And if you work that out on your fancy schmancy calculator, it's 155.25 people. You don't have to write people because it didn't ask for units, but if you want to write people, you can. And again, this simplified answer is not necessary because if you make a mistake on that, they would lose points. So it's not wrong, but all you need is a previous line. Bam, 2 down, 2 to go. We are on fire. The next one, we have to get really nerdy on you. Sorry, but you need to know your theorems. So this one's crazy. You want to know how many times L prime of t must be 0. So we're going to use actually 2 different theorems here. So to be 0, we know if it goes from a positive number to negative, it must cross 0 and vice versa using intermediate value theorem. But we need to know what the derivatives are at certain points. But here's the beauty. We are told that L is twice differentiable. So therefore, we should write, since L is differentiable, therefore, we know L is continuous. So we need differentiability and continuity for the mean value theorem and continuity for the intermediate value theorem, which we'll get to. And that's actually not going to come from the first derivative, but second derivative. We'll talk about that in a second. So let's look at this. Because these two are true, we know that the derivative must equal the average rate of change between 2 points. Now, if you look between these 2 points, the number of people increase. So if you find the average rate of change between those 2 points, which would be 156 minus 120 over 1 minus 0, clearly it's positive, it increases. Now, between the next 2 points, Again, the average rate of change is positive because it increases. So that's a plus. I'll put a plus there. I'll put a plus here. So you could probably argue, just say the average rate of change between 0 and 1 is positive. Therefore, the derivative must be positive in that region. Same thing for 1 and 3. And now we notice from 3 to 4, the average rate of change is negative because the number of people decreased. So you can just say, since average rate of change between 3 and 4 is negative, therefore the derivative must be negative in that region by the mean value theorem. And then let's go to another region. Between 4 to 7, the number of people increase. So if you were to find the average rate of change, f of b minus f a or b minus a, you would find that comes out to be positive. So you can argue that because the average rate of change is positive, the mean value theorem guarantees that somewhere between 4 and 7, the derivative has to equal that, which is positive. And then if you look between 7 and 8, I'm out of colors. Which color do you guys want? Ooh, that pinkish, peachish. That looks good to me. So between these two, if you look, it decreases. So you're guaranteed that the derivative must be negative in that region. And then one more color. Let's do baby blue. It decreases. If you were to find f of b minus f a or b minus a between these two, again, it comes out negative. So let's take a look. All of these are L prime of t. So you see that it's positive, positive, negative, positive, negative, negative. So L prime has to go from positive, negative, and then negative, positive, and then positive, negative. That's got to be 3 times that it's got to happen to equal 0. But for that to happen, L prime would need to be continuous. So we should say, since L prime is differentiable, therefore L prime is continuous. Now, since L prime is continuous, the intermediate value theorem applies. So the argument would go, since between 1 and 3, the derivative had to be positive, and between 3 and 4, the derivative had to be negative. Therefore, it had to equal 0 at some point between it by the intermediate value theorem. Then that same argument, since between 3 and 4, the derivative is negative, and between 4 and 7, it went to positive. Therefore, by the intermediate value theorem, L prime of t had to be 0 between those 2 points. And the same thing, between 4 and 7, it had to be positive, and between 7 and 8, it's negative. Therefore, since 0 is between those, by the intermediate value theorem, L prime of t had to equal 0. So therefore, you get a conclusion 3 times. That's a lot of splaining. But I am done with that one. That was 3 points for that splaining. We have one more to go, and this last one's really easy. Hopefully, we're going to finish this pretty quickly because, like I said, the last one was long, too long. All right, part D. So let's highlight some stuff here. The rate, so it's a derivative of the number of tickets sold, is modeled by R of t. Based on this model, how many tickets are sold by 3? So if you know the rate at which tickets are sold, if you integrate a rate, it tells you the change in what it's the rate of. Since it's the rate of the number of tickets, it tells you how many tickets were sold. So part D is quite nice. You just integrate from 0 to 3. Your function R of t dt. Pop that in your fancy schmancy calculator. It comes out to 972.784. But let's read the question. It says to the nearest whole number, so the answer should be 973 tickets were sold between 12 and 3 o'clock. Is that right? Yes, between 12 and 3 o'clock. Bam! That's pretty awesome. We are done. 2 down, 4 to go. Bye.